Yes.
Yes. Okay with that?
Is there every time you just leave that in terms of radicals?
Yeah, I'm just showing you where these points are going to show up, and it's hard for you guys to plot a radical. Like, I don't think you guys are good at, like, where is root 2 over 2? Okay, less than 1, but great.
Yeah.
All right, what about pi over 3? And you do not need a calculator for this one. What's r going to be if theta is pi over 3? You guys did just take a trig quiz, right? You should know these things.
I use all the trig energy I have.
Negative 3 over 1/2 is
Yeah.
negative 6. Okay. All right, guys. Pi over 2. Any issues there? Yeah, because cosine pi over 2 is 0, and we're dividing by 0. Yeah, so that doesn't work. That's undefined. We're not going to be plotting that guy. Let's do a negative angle just to make sure you're okay with that. Negative pi over 3. Good. Excellent. Your brain has to like mush a whole lot of things together to do these. All right, so let's plot them. So my radius is negative 3, my angle is 0. So there you go, right? We got a dot. Okay, now my radius is negative 4.2, so I'm going to the left, and I have to travel pi over 4. So which quadrant does that put me in? Good. 1, 2, 3, 4 in the middle. All right. Negative 6 pi over 3. Where does that put me? Still third quadrant, right? It's like down here. What about negative 6 negative pi over 3? What does that do? Takes you second quadrant, yes. Okay. What do you see?
It's just a vertical line.
It is a vertical line, okay. So let's try.
Well,
It's crooked.
for r sine theta equals 2, will that be a horizontal line?
Hold on. Let me explain one more thing with this one. Okay. Look at your equation. We had r cosine theta equals negative 3. You guys know from converting, what is r cosine theta?
X.
Oh, so x equals, so vertical line at negative 3, right? So don't plot points for the next one. What are you going to tell me? Okay, so that's going to be a horizontal line at 2, right? Yep.
So is it okay if we don't plot points?
Totally okay. That's actually the goal with a lot of these, is you're going to be like, oh, I know that's a line, draw it. Oh, I know that's a circle. Here, I can draw it. Yeah, they're a little tricky. I struggle drawing them up here. Okay. So we have 3 different ways we might see a line. The only way you get an angled line is this, if we're talking about the slope equaling tangent of theta. And then you're either looking at x equals a number for a vertical line, y equals a number for the horizontal line. Okay? So lines, we feel pretty good about, right? Those are not too tricky. Okay. I just have to find my way.
Those r cosine theta, r sine theta, that have horizontal or vertical?
Nope.
Oh, because you can just subtract.
Did I get rid of it? There, guys, hold on. Okay. This one. We have r equals 5. All right. Not a line, right? Not theta equals something. It's r equals 5. So I'm gonna, it should be a circle, but let's look at why it is. Let's plot a few points here. If theta is 0, what is r? If theta is pi over 4, what is, okay. If theta is pi. If theta is 3 pi over 2. Good job. Do I need to keep going or do we get it? 5. Yes. 5. All right, so I'm just counting out 1, 2, 3, 4, 5. I go 0 for my angle. I go pi over 4. And we're going to go pi over 5. Go 3 pi over 2. I've got negative angles. What's happening the whole time? I'm going to cheat for my circles.
Oh, that's cheating.
Totally cheating, I know.
It's harder to draw on here that like geometry thing.
Oh, geometry sketch pad.
You know the like where you like had to stick it in and like you move your pencil.
Oh, the compass for constructions?
Yeah, those are so hard.
Oh, yeah.
Geometry is like painful memories for some reason. All right. So guys, if it just says r equals something, you know this is a circle.
You get one of those graphs on the test.
You might. Center at the pole, okay. Radius of 5.
Will you ever be given an equation that's in halfway between rectangular form and square form?
No.
Like any
Like if it was like r equals 5x.
No. No, no, no. All right, let's look at the next one. Okay, we're going to do points one more time here. We're going to plot points again. So let's think about our angles. So if theta is 0, what does r equal with this equation? Good. What if theta is pi over 3? Yes, I'm only picking ones that are nice. -1. Good. Pi over 2.
0.
0. 2 pi over 3.
Negative 1.
1 pi. 2. Okay. What do you think is going to happen if I keep going into like 4 pi over 3 and 3 pi over 2? If I keep going, am I going to see any different values really? No, they're going to get repeated. Okay. So -2 and then go 0 for my angle. -1, go pi over 3. That's putting me into the third quadrant. 0 is going to be the pole. 1 is going to give me 2 pi over 3. 2, I'm all the way back to pi. Not a super defined shape. What's your guess? Arrow. It is actually a circle, guys. If we had plotted the pi over 4s and the pi over 6s with their decimal values,
Oh, it's maybe an explain.
you would have seen, let's see, here's pi over 4, you would have seen a little more like this. Okay.
oh.
So, it is a circle again. But it is not centered at the pole. Oh dear. Leave that. Okay. So, what would you say about this circle? Where's the center?
Not at the pool.
Not at the pole. I like that. Let's say would you say shifted left,
One.
essentially?
One.
Yes.
Okay. And let's go, what's the diameter?
Two.
Okay. So now, think about it here. Negative, right? So what do you think that tells me? What's the negative to make it 2?
How do you know the diameter?
Oh, 1%.
It's just from 0 to 2 like this, yeah. Yes, that's it. It's negative, so I know I'm either going left or down, right? Those are the only ways I can go negative. It's cosine. So x left, yes. If it had been sine, where would it have gone?
Down.
Okay. This is 2. What was my diameter? 2. Okay. So, what are you going to tell me without plotting points about this guy?
It goes off 4.
4.
Okay.
Diameter is 3.
Yes. I'm just going to cut.
When it's like this, we'll always touch.
Yep, it's always got something like connected to the pole. There you go. So the cosine and the sine, if you see those when you're looking at a circle, that determines which axis it's been shifted on. The diameter is that coefficient in front. So the diameter's, so the top's going to go to 4. And then you just sort of make the sides make it look like a circle. I mean, there's not like a happy point to plot out there.
When you're graphing these, like, do you have specific points, or can you just like look at it and then just like graph it?
You can just graph the circle like that. There will be matching on your test.
Okay.
So it'll be like, okay, here's all these different equations. Here's graphs, match it up. The other thing we're going to do in the notes today is graph over a specific window. So then it's going to matter like which points you use. But other than that, no. All right? We okay? Okay, so let's look at sort of formally defining what these things mean. Let me erase some stuff down here, guys, and then I'll go back up. So guys, read through what I have up here. On the left side are your circles, and on the right side are the 3 ways we looked at lines. Remember that first one, we're talking about slope is whatever tangent of that angle is. Feel free to write exactly what I have if you want to write it in your own words, whatever makes the most sense to you, okay? And if you need me to read any of that to you, let me know. Like if you can't read what I wrote. Same as their part, you're stuck on. I will try. Well done. Okay. Is that better? Okay, yeah.
Yeah. And then, well, okay, I guess it was a big sale because I had a $40 gift card. Also, if you're a rewards member, are you a rewards member? I think I'm a rewards member. But I had like if you like participate or whatever, and you're there, they have like giveaways and stuff, and we like participate in them. Then you like earn points, and then they give you like $5 off or something. And so I had a $5 off. So I bought like 50.
Hey guys, side conversations. Let's stop so I can hear questions. Yeah.
So the middle line is pi over 4, and the next is pi over 3 and pi over 2. So what are the two other columns at the end?
Pi over 12 and 5 pi over 12, which you really don't need. It's just, if you think about it with radians, it was 30 degrees to the first radian, and then 15, 15, 30. So they're just giving you lines at every 15. Yep. Yeah, see the extra.
Are you like graphing out like pi over 12 or everything?
Yeah, sometimes it's like, wait, there's too many. Excuse me. All right, are we ready to graph on an interval?
Yes.
Oh, good. Like the enthusiasm. Okay, let's see. I can go back to. Okay. So the first one here. Okay. I think you have less than or equal to on both parts, right?
Yes.
Yes, okay. Alright, so the first one, r equals 5, and then I gave you this interval 0 to pi. Okay. What is r equals 5? If you forget about the interval, what is that? Circle, okay? Radius of 5, right? I am now yes, centered at the pole, good. I'm telling you I only want you to graph it from angles of 0 to pi. What do you think that means? Okay, this one ends up being half a circle, yes. From here to here. Hopefully you draw nicer than I can. Well, let's think about it. So first one, pretty easy, right? Okay, second one, -5 now. What, will that change anything?
Do the other half of the circle.
Yeah, because remember, you go the radius first, so I'm over here at -5, and then I go 0 to pi. Okay. Exciting, right? Okay, so over here, here. Whoa. I wish I could cheat on my semicircles too. Okay, well, that's pretty. Alright, now the next one. Don't be scared because it says 4 cosecant. Okay, I've given you an interval here. I want you to cross it out. We are not going to do this interval. I'll explain why here in a minute, but forget that. Okay? Let's figure out what 4 cosecant of theta really is. So would you guys agree that this is the same after lunch, I guess? I'll see. Alright guys, so this one, we got to this point where r equals 4 over sine of theta. Are we all okay with that? That's what cosecant means?
Yeah.
So would you agree then that this is the same as r sine of theta equals 4?
Yeah.
Okay. What does that mean? Y equals 4. So what are you going to graph? Okay. Vertical, horizontal, what are we looking at? There we go. Done with that one. Easy? Okay. The next one, we've got a little bit of work to do to look at our Why what? Yeah, with lines, it's actually really hard to graph over an interval. Because if we did the interval that's there, it like stops at one axis, but it goes out to 30. Like it's just terrible. So I'm not going to give you windows to use when you're doing lines, okay? What do you think this is, though? What's r equals -3 sine theta?
So,
That is a circle, okay? If there was no interval, what would this look like?
Circle down.
Yeah, it'd be down, below, diameter of 3, okay? Because of this, we have to figure out which part of the circle we're actually looking at, okay? So, I am going to make a little chart here. And when you do this, you want to go in order with your angles. So, I'm starting at pi over 2.
Wouldn't there be nothing?
There's definitely going to be stuff, so just hold on. I'm not talking about on the graph here. I'm saying if theta is between these values, what does r equal? Like, you're not just graphing that this is your circle, okay? That's where do the points end up. Because every time theta is pi over 2, you don't get a point up here,
Okay.
right? Okay. We'll start with pi over 2. What do I get when theta is pi over 2? -3, yes. Let's do, the over 6s are easier, so let's do 5 pi over 6. What would I get there? -3/2, right? And then I'll go to pi. That's the end of my points then. What do I get at pi? 0. Okay, now what I mean about plotting and doing these in order. I'm going to plot these and then I have to connect them in the order that they go through these angles, okay? So -3 and then pi over 2, where's that going to be?
No.
Not really in a quadrant, where is it?
it's on the line.
Okay, like down here. Okay. Then I'll go -3/2 and travel 5 pi over 6. Okay, with that being here. Okay. And then the last one, 0 pi, that's just at the pole, right? So do you guys see if we connect them in order, that's all we've done? Does that make sense? No, it's just to help you recognize like which piece of the circle you're looking at. So, and guys, how big, like pi over 2 to pi, that's not very big, is it? Like that's 1 quadrant of your original circle. But how much of an actual circle graph did I get? Half of it. So how, like, what do you think you need to graph an entire circle? Really just 2 quadrants, right? If you're graphing like 0 to 2 pi, you're really just tracing over that same circle twice.
Is it possible to make it in 3 quadrants?
Yeah, you could. And then you'd still see a whole circle. I mean, I could have given you like a quarter of a quadrant or, you know, but probably not going to do that. All right. This, especially this last one, you're going to want to pay attention to that on your homework. But questions before we get to the homework?
It's between pi over 2 and pi. Isn't that the second quadrant?
Okay. Theta, which is right here, theta is between pi over 2 and pi. The values you can plug in for theta. Okay. Because think about sometimes if we have a negative angle that I go pi over 2, that's down here. Right? Okay. All right. That's the end of your notes then. Your homework is the next page. Well, it's the right side of the worksheet you guys are on. It's 6 graphs and that's it. We will get to the extra practice for 8-2 eventually, but I'm not checking that next time. You have an abundance of time to get your homework done. Okay? Maybe.